Hello and welcome back to Calculus 1, section 4.7 on L'Hopital's rule. It's actually not L'Hopital's rule. It's now I'm not going to go into the whole story. I forgot to start the stream. So in short terms, Bernoulli's rule and L'Hopital published the first calculus textbook. There you go. All right. So now we are going to see what the L'Hopital rule is. This is why you should come to class, right? So, if we have an indeterminate form 0 over 0 or infinity over infinity, the result of the two limits below is the same. Limit x goes to a of f of x divided by g of x, L'Hopital on the equal sign, equals the limit x goes to a of f prime of x divided by g prime of x. Over here, this time in blue blood, I guess, this is not quotient rule. It is not a quotient rule. It is two independent, separate derivatives, derivative of the numerator, completely separate from the derivative of the denominator. They have nothing to do with each other. The interesting part here is that even though you are completely changing the problem, the limit of the problem remains the same. So the first example that we are going to examine is the one that I mentioned before and said you have to wait for 4.7 to see how's that limit done. And that limit is limit x goes to 0 of sine x divided by x. So this is the limit which I told you it's equal to 1. Memorize this because we needed the proof for limit of sine is cosine. So when I did f of x plus h minus f of x over h, right, I used this limit in there. And I just said, trust me for now, 4.7 will clear it up. Well, it's time to clear it up. When I plug in 0, because we know that the fastest way to solve the limits is to just plug the value in and hope nothing explodes. Well, in this case, you plug in 0 and you get sine of 0 is 0 divided by 0, and this is where you have your indeterminate form of 0 divided by 0. If that is the case, and in this case it is, you can take independent derivatives, so L apostrophe H, copy the limit x goes to 0, and now take independent derivatives. Derivative of sine is cosine, and derivative of x is 1. When you plug in 0 now, you will get 1 over 1, which is 1, and there is your answer that the limit of sine x over x is equal to 1. Great. So now we have this limit, and we can immediately take a look at another limit from our past life to sort out the same way. So limit x goes to infinity of 3x squared plus 2x divided by 9x plus x cubed, whatever. Those of you who, let's go with x squared. Let's do 1 plus, like that, so we can't cancel. So those of you that know your pre-calc well, or you know your calculus well, you already know what the answer of this limit is, right? The highest powers are the same, square and square, which means that the limit is the front coefficients.
It's a slant asymptote?
No, the same powers. If the power is bigger by 1, it's a slant asymptote, but this is square and a square. Because it's a square and a square, it's just front coefficients, which is 3 over 1, which is 3, which is also your horizontal asymptote. It is the limit at infinity from 2.5. So you can solve this by dividing each one by x squared, right, which is the highest exponent. So you know how to do this in multiple ways. The boss way is to use L'Hopital's rule, right? So what do we do with L'Hopital's rule? You plug in infinity, and you quickly realize that this is infinity divided by infinity, which means we have indeterminate form. Indeterminate form means infinity over infinity, and we can use L'Hopital's rule. So I'm going to put L apostrophe, that was a good one, H, and now we take independent derivatives. So limit x goes to infinity. The derivative in the numerator is 6x plus 2, and derivative in the denominator is 9 plus 2x. Now, you will plug in infinity again, and you will get infinity over infinity again, which means that you can use L'Hopital's rule again, and that's going to give you limit x goes to infinity of, and now when you take the derivative, you will get 6 divided by 2. 6 divided by 2 is equal to 3. There is no x there for us to plug in infinity, so the limit is just 3, as we have foreseen. Now, let's say you care, right, and you want to check these answers. The way to check the answer is to graph the function, let's say Desmos, Mathematica, whatever. And if you remember from chapter 2 that the limit is the y value, right, at where the x goes to, you can just look at the graph and just make sure that the y value above 0 for the first example is 1, and that in this case horizontal asymptote is at 3, so that the function will go on the level 3. So you will just graph these in Desmos, and we're going to take a look at a couple of more examples before we get into the spicier stuff in this section, which is, you're going to see 0 times infinity, infinity minus infinity, and a whole bunch of other stuff. Yes?
So the way you found the derivative twice, could you do that infinitely?
You can do that as long as you are keeping infinity over infinity or 0 over 0.
So like...
Could be 2 steps, could be 7 steps, depends on the problem.
Okay.
How far should you go, or how would you know if it actually will equal anything other than 0 over 0 or infinity over infinity? Like, did you knew that because you have experience. Like, if I take the second derivative, I know it'll equal a number. But
yes.
How would we know? Do we stop at 2? Do we stop at 5? Like,
you build the experience by doing problems. That's the fast answer. Now, the next part is as soon as you don't have 0 over 0 or infinity, the process is broken. So you have on the first example that we had 0 over 0, and you used L'Hopital's rule, and now you don't have 0 over 0, you don't have infinity over infinity. That means L'Hopital is out, right? It's out. And when I plug in 0, I got 1 over 1, so we are done, right? Because we did get this. Now, in this case, the second problem, we used L'Hopital and infinity, and it was still infinity over infinity. You get to do this, but then if you see that your values, which we are going to run into those problems, is you are taking these derivatives, they're not helping, they're making it worse, then you will have to figure out and flip things around. So we'll see that as well, right? But the answer to your question is experience, right? Which is, for now, obviously. When do these problems really count? In Calc 2. when half of the course depends on your ability to do this. Right now on your exam 3, you're going to have 2 problems, on the final maybe 1. So you passing the course doesn't necessarily depend on this method, right? It's just 1 lecture out of 9 in chapter 4. At best, you got to get 2 problems on your exam 3. But what I'm telling you is there is no second half of your Calc 2 if you don't know this. By that time, you will have enough experience. That's the talk we're having. Okay, I'm going to Desmos now to get our graphs and show that this works. So I have the sine x divided by x, and what we see is that at 0 limit is 1, right? We all see that. So that's our first problem. The second problem is given as 3x squared plus 2x. Plus 2x divided by, and I have 1 plus 9x. 1 plus 9x plus x squared. And as soon as I draw this, what we see is the horizontal asymptote. Hard to see, but horizontal asymptote at 3, right? Horizontal asymptote at 3. So here is the 3, and as you can see, the line is climbing up to meet that 3. It's not going to touch it, not going to cross it, but cool. So now you understand, hopefully, how to check these problems. And again, limits just provide the y value. Remember, the first sentence in the semester was, what's a limit? The street definition. Just a fancy way to compute the y value, right? So now we know y value in this case is 3. So I'm just going to pull up a couple of examples from homework so that we can see other, and then we're going to do more interesting cases, because these are the base cases and the other cases are going to go into this eventually. Let's see. L'Hôpital. All right. So try this one on your own because you're already pros at this. E to the x minus 1 divided by 5x squared. What's e to the 0?
Is that 1?
1. So 1 minus 1 is 0, so we have 0 over 0. Take the independent derivatives. No quotient rule. Independent derivatives. And then check.
So top would be just e to the x.
Because once you get this 30, right?
Yeah. Bottom 10x. Yeah. Okay.
And then right, because it's 10 for x.
What's the derivative of 1?
But then 10x times
So
0,
it's
so you get 0
oh,
over 0.
Yeah, you put
And then you do it again.
minus 1.
You find the derivative of e to the x minus 1 over 10x. So here's the hospital again. Since you said that, if you plug in 0, it just becomes 0 over 0. You can use that. Oh. Pretty sure. If I'm getting this correct.
But I thought that was only when x is approaching infinity. Positive or negative. That's what I was understanding.
It might be that.
This chord is long. This was the picture.
Yeah. What biome
Is that what you got?
That's just e to the x. I just kept on doing 0. Yeah.
Oh,
Wow.
so he did.
Because if you take the second, so this is the
Now,
first
the way
derivative.
he did what you did,
Then you take the second.
that actually makes sense to me.
Oh,
Sort
oh,
of more.
okay.
But
Alright.
see, I thought you couldn't repeat it if x wasn't approaching infinity.
Zero or infinity.
Oh, zero or
If it's 0 over 0 or infinity over infinity.
Yes.
Okay.
Sweet.
You can't mix match them, it's just one. All right, so we have e to the 0 is 1, minus 0 minus 1 is 0. And then 5 times 0 is 0. So we have 0 over 0, we can take derivatives. Again, independent derivatives. So derivative of e to the x is e to the x. Derivative of minus x is minus 1. Derivative of minus 1 is 0 divided by 10x. We plug in 0, we get 1 minus 1, we get 0 again. Oh, I forgot to put L'Hopital over here. There we go. So now we can do L'Hopital again, which will give me a limit. X goes to 0. So now when I take derivative, I get e to the x divided by 10. Now when I plug in 0, I get 1 over 10. There is no 0 in denominator anymore, no the infinities or anything like that. So that's just the basic limit now. And we have the answer. You go to Desmos, you graph it, and you will see that as x goes to 0, which is the y-axis, the y-intercept is 1 over 10. Cool beans. Let's see what else. Oh, this is a... Because... All right, ready? Lock the doors. Tangent inverse of x minus... Look at that song, how much they love this.
The song
It's-
of look at that.
What is the inverse tangent of infinity?
Infinity?
Inverse tangent of infinity is? This is where the graph of inverse tangent is very useful.
Useful to whom?
To thee who wants to find the limit as x goes to infinity. Thee who knows the graph shall know the answer. So what is the derivative? What is the limit as x goes to
Pi over 2.
pi over 2? So pi over 2 minus pi over 2 is 0, and then 1 over infinity is 0. We have 0 over 0, so we can unleash L'Hopital. Limit x goes to infinity. And now we have to take independent derivatives. What's the derivative of inverse tangent?
1 over 1 plus x.
Excellent. And then derivative of pi over 2 is 0. Divided by what's the derivative of 1 over x?
Negative 1 over x.
Beautiful. So now we are going to work out this double fraction here to come up with negative x squared divided by 1 plus x squared, right? When you multiply 2 on the outside and 2 close by. So we have this. Now, when you plug in infinity, what happens? Yeah, we get infinity over infinity, which means we can unleash L'Hopital. This time, we get limit x goes to infinity of negative 2x divided by 2x, and now the whole thing cancels to negative 1. So the limit for this should be negative 1. And then you go, you graph it, you verify it, and then you move along. Since you did so great with these, let's do another one. Because I know how much you appreciate trig. I don't want to, deprive you of that pleasure. So, tangent x divided by 3 over 2x minus pi. You got this.
So that's x goes to pi over 2?
From the left, yes. The minus sign means from the left.
one, and then and then I guess you just put 2 times pi over 2.
That's pi plus pi.
2 pi over. No.
All right, so this is one of the tough problems, and if you are not doing well over here, well, this is, you know, S tier. You have the, yes.
Would it be
7? No.
no.
42?
5.
Would it just be 0?
All right. So let's take a look at this. This one is a tricky problem because it's not clear, right, once you take derivatives. So here we go. Plug in pi over 2. Now, tangent graph has the asymptote at pi over 2, so that's infinity. So we have infinity. And then you have 3 divided by 0, which is also infinity. So you have infinity divided by infinity, and we can unleash L'Hopital. So limit x goes to pi over 2 from the left. And now derivative of tangent is secant squared x. And the derivative on the in denominator is going to be negative 6 over 2x minus pi squared. So now if you plug in pi over 2, secant is 1 over cosine. So this is 1 over cosine squared. Cosine of pi over 2 is 0. So we still have infinity over infinity. And as you can see, we went from a single tangent into a squared secant. We went from a single denominator, right, to the squared denominator. So we made problem worse without achieving anything. Previously, when we did the derivatives, we made the problem better. And then we did it again, and we solved the problem. Remember that we had the derivative, and then that took us down to this, and we could take another derivative. You would get negative 2 over 2, right? So it is okay to keep taking derivatives as long as the situation is getting better. But if you keep taking derivatives here, the chain rule of secant will give you secant tangent, right? Then you would have the next time the product rule. So as you take derivatives step to step, it will always be infinity over infinity, no matter how many steps you go, and it will keep getting worse from having a single derivative into having a chain rule into having a product rule. It just keeps getting worse. So what do? Well, we then look for algebraic step to flip the problem so that we can get out of that situation where you are taking these derivatives and you're just making situation worse. So what I'm going to do now is I'm going to bring these secants so what do I have? Since this is my main division line, on top I have technically 1 over cosine squared, and on the bottom I have negative 6 over this. So I'm going to bring this 2x minus pi squared here, and in the denominator I'm going to have negative 6 cosine squared x. What have I done? I just did the double fraction a over b over c over d. So I dealt with a double fraction where secant is 1 over cosine. So 1 over cosine squared in this case. So you have the double fraction where you multiply two that are far apart. So 1 times 2x minus pi squared. And then 2 that are close by is minus 6 cosine squared x. So now I have these. And from there, let me check. See what happens now. When I plug in, I get 0 divided by 0. So I am still able to use L'Hopital's rule and take derivatives. Make sure you write limit every step. until you use it in the last step. So now when I take the derivative, in the numerator I will get 2 times 2x minus pi times the derivative of the inside, which is 2, divided by negative 12 cosine x, and then I have the derivative of cosine is negative sine, so that will kill the negative here. Awesome. Let's use some algebra here. So 2 times 2 is 4, divided by this gives me a 3. So I have 2x, I forgot the limit, points off. Limit x goes to pi over 2 from the left, and we have 2x minus pi divided by 3 cosine x sine x. Now, what's the power move over here? Power move is to combine this sine, cosine.
Did we get rid of the negative with something? Negative 6?
Yes, because the derivative of cosine is negative sine.
Okay.
And that negative killed the negative in front of 6. Yes, okay. All right, so the power move over here is to 2x minus pi divided by 3/2 sine 2x. So what I did, you don't have to do this, but it's much easier because of the derivatives. So you don't have to do the product rule. Chain rule is easier. What I did is I condensed the sine x cosine x into sine 2x over 2, and then gave the over 2 to the 3 up there. So now, what do we get? We get to consider the limit x goes to pi over 2 from the left, and you bring this 2 upstairs, so you have 2x minus pi divided by 3 sine 2x. And now when you take the pi over 2 inside, pi over 2 will give you sine of pi, which is still 0. So we have 0 over 0, and we can use L'Hopital again. And I think this is the last time, because we should be able to solve it. The derivative in the numerator is 4, because derivative of 2x is 2, and then times 2 in front. Derivative of minus pi is 0. So derivative is just 4, and the denominator, derivative of sine x is cosine x, and 2 jumps in front, 6 cosine 2x. So now, when you plug in pi over 2, it becomes cosine of pi, which is negative 1. So, when you plug this one in there, you will get 4 divided by 6 times negative 1. And that's going to be negative 2/3. So the answer for this limit is negative 2/3 or 0.666, right, going on forever. So let's check if that's the case. And I'm going to see, I lost the problem. Oh, there it is. I always wonder if I can. I don't think I can now. All right, whatever. So we're going to Desmos now, and we're going to graph this monstrosity. So what do I have? I have tangent x divided by, so tangent x, that's busy, divided by, open parenthesis, 3 divided by 2x minus pi. $2x minus pi. Awesome. So, all right, what am I looking for? I'm looking for the limit at pi over 2. Pi is 3.14, so pi over 2 has to be about 1.57, right? So we're going to zoom in at 1.57 over here, which, there it is. And look at its y value, negative 2/3, right? This is how you check your answers. Limits are computing y values, right? So your answer has to be the y value for the x point when you say x goes to a number. And we just show that. All right, so this one was spicy. A lot of mathematical formulas and algebraic manipulations, but this one would close the basic indeterminate forms 0 over 0 and infinity over infinity. We are now focusing on the next set of problems, which is 0 times infinity case. To solve this case, you need to know a formula which says f of x is equal to 1 over f of x. So this is the transformation that we are going to use to transform our problems into known problems. So let's go and see if we can find something this book doesn't have, unfortunately, a lot of cool problems. So limit of x goes to 0 of x times cosecant x. Well, this is 0 times infinity. And again, now this is where some of you are going to lose it. You have two choices. One choice is to go 1 over cosecant x, and the other choice is to go cosecant x divided by 1 over x. Because you can put either of the two in the denominator using the transformation above. You see, if your f of x is x, then you write it as 1 over x. So 1 over x. If your f is a cosecant, then 1 over cosecant. Right? So you can be either one. Which one is going to work? Well, you try them both. Maybe you hit on the first run. Maybe you have to do the second one. So let's go and try the top one. Again, experience, right? So I'm going to do limit x goes to 0 of x divided by 1 over cosecant x. Now, what's 1 over cosecant x? Sine x. Very good. So this is now equal to the limit x goes to 0 of x over sine x. And we know that's 1, right? But let's unleash L'Hopital. So now we have 0 over 0, which means L'Hopital. We get limit x goes to 0. You get 1 over cosine x. And that is 1 over 1, which is 1. So we have the problem solved. And again, it's going to be, at first, trial and error. Later on, experience to know which one to pick. Now, general rule is, if you are making a problem worse, run the other way, all right? Clearly, you make the wrong choice, which is okay, right? We make wrong choices, and then we correct them, hopefully later, because that's a human thing to do. It's okay. Let's take a look at exactly. Another problem. Try limit pi over 2 minus x times secant x as x goes to pi over 2 from the left. All right, so which function do we get to switch? Because we do have 0 times infinity. You have pi over 2 minus pi over 2, that's a 0. And secant of pi over 2 is infinity. What's secant? Secant is 1 over cosine, right? And cosine of pi over 2 is a 0, so 1 over 0. That's giving us infinity. So what I'm going to do is I'm going to use the trick first, right, the transformation. So x goes to pi over 2 from the left. And we're going to leave pi over 2 minus x and then put 1 over secant x here. And now we're just going to change that into a cosine. But now you have 0 over 0, right? So I'm going to first rewrite this as the limit x goes to pi over 2 minus, and then I'm going to have pi over 2 minus x divided by cosine x. And that is going to be now, again, 0 over 0. So we are unleashing L'Hopital. X goes to pi over 2 minus from the left. And now the derivative in the numerator is negative 1. Derivative in the denominator is negative sine x. And the whole thing becomes 1. Because sine of pi over 2 is 1, minus signs canceled. And this should be 1. That means that if I am to go on Desmos and graph this one, we should have the value of 1, and that's how we deal with 0 times infinity. You will use the 1 over f to transform 0 times infinity to either 0 over 0 or infinity, and then use the regular L'Hopital rule to solve the problem. So let's just really quickly graph this. I'm going to have pi divided by 2 minus x, and all of that is going to be multiplied by secant x. You can see it. So now you can see it, and you can see that this point here is pi over 2 comma positive 1. Again, limits are calculating the y value of the function. You don't have the access to your graphing utility on the exam. And because you don't have the access to the graphing utility, you can't pull this off to read the answer off of the graph. But as you're learning these things, it's a very valuable tool for you to check that you know, right, that you're doing things correctly. Well, my math lab will give you fantastic, right? Use the study plan. Lock the doors. Infinity minus infinity case. How much is infinity minus infinity?
0. Infinity. Negative infinity.
And all of you are correct. And now I'll put in like 3/4 and I'll put in, other values in there. But yes, infinity minus infinity works out to be infinity, works out to be 0, works out to be 1/2, and all these kind of things. It will depend on the functions involved as you subtract. So the biggest issue that we are running into when we have infinity minus infinity is the situation that we can only deal with the L'Hopital rule with the infinity over infinity or 0 over 0. So we need to convert this into either 0 over 0 or infinity. How do you go from subtraction into division? Because division is the one that utilizes 0 over 0. That's a division. So how do you follow mathematical steps to go from subtraction into division? But no.
Multiplication?
You go to multiplication first, and once you are in multiplication, you use the trick. Now, how do you get from subtraction into multiplication? What mathematical concept will get you subtraction into multiplication? No, the other F. The other F word. No. No.
Factor?
Factoring. Very good. Yes.
Oh, dude.
Yes. You have fractions, factoring, foiling, like all of these F words in mathematics. So this time was factoring. So let's take a look at one of the staple examples. Let's go with a limit of x minus square root of, lock the doors, x squared plus 4x as x goes to infinity. So what do I have here? Well, definitely infinity minus infinity, because when I plug in infinity, that's infinity, and then x squared is infinity, square root of that's just infinity minus infinity. So we have this. Our goal is to factor, well, what's common between the two terms? Currently nothing, which means that I somehow have to make an x in front of the root so I can factor it with the x in front of the minus sign, which would create multiplication, and then use 1 over f to get into L'Hopital form, right? So we start by factoring out x squared under the radical, so we can kick it out as x. So when I factor out x squared, it's left with 1 plus 4 over x. Do we all see that? When I factor out x squared, it's 1 plus 4 over x. Are we all bueno? If you don't understand this step, the rest of the problem doesn't exist.
No, I don't understand how. So it's still under the radical though.
So now it's going to go out as a single x, but I just needed to factor it so I have x squared that I can kick out. In the next step, it goes out. My concern here is from here to here, do you guys see factoring x squared? That's the step that we need to understand. Once you understand the factoring of x squared, now you get to kick that x squared out, and you just have that. Just crickets on the other side. I factored. No one had the issue with derivatives. Product rule, chain rule, right? I factored. Dead silence. It's like, did he kill them all? Like, no, he factored x squared. Hush falls in the classroom. All right. Triple product, not a problem. Factor x squared. What? We need a meme for that. Someone get ready. No, I need that guy with the. Yeah.
Oh my gosh.
Yeah, that's the one I need. Get on it. So now we started by understanding that I need to factor to create multiplication. When I create multiplication, then I change that into division, because our L'Hopital is division. Infinity over infinity, 0 over 0. Right? So now I am going to factor this x. And we're going to have 1 minus the square root of 1 plus 4 over x. And now we are at that infinity times 0 state. Because when you plug in infinity, 4 over infinity is 0. So you just have 1 under the root. Root of 1 is 1. So 1 minus 1 is 0. So the whole parenthesis is 0 times infinity. This is where you use the trick 1 over. So now use 1 over f. And we get limit x goes to infinity of 1 minus square root of 1 plus 4 over x. I don't need these parentheses. Divided by 1 over x. And now you have 0 over 0. And you just need to take these derivatives. And then we can do the limit. Denominator is easy. It's just negative 1 over x squared. You memorized that by now. Derivative of 1 over x is negative 1x squared. It's all cool. Numerator is what we worry about. What do you have in the numerator? Well, you have 1 minus, well, derivative of 1 is 0, so don't worry about that. We have a derivative of a square root. And derivative of the square root is 1 over, and it's going to be negative 1 because of the negative in front of the square root. Negative 1 over 2 times the same square root times the derivative of what's under the square root, which is going to be negative 4 over x squared, because derivative of 1 is 0, and derivative of 4 over x is going to be negative 4 over x squared. We need to clear a little bit of this algebra. You have 3 negative signs, and those need to be all combined and so on. So let's see what kind of algebra we can do this. Kill the 2 and the 4, get a 2 over there. Multiply top and bottom by x squared and combine all minus signs together. Awesome. So denominator is gone completely because x squared and x squared would cancel, and the negative combined with the other negative, so there's nothing in denominator anymore. It's not going to be a double fraction. So I have a negative 2 on top, and on the bottom I have x squared and x squared canceled. I have a square root of 1 plus 4 over x. So when I take the limit over here as x goes to infinity, I get negative 2. Who would know? Infinity minus infinity equals negative 2 in this case. What was that? Okay, no problem. One more. Sure. Try to factor and go through the steps alone. X goes to infinity. X minus square root of x squared plus 1.
No.
Yes. I think so. You graphed it on your to verify. Okay, so let's go. We factor x squared, which will give us 1 plus 1 over x squared. And then that x squared goes out as x. So now we have x minus x square root of 1 plus 1 over x squared. And then we have what? We have factor out x. So limit x goes to infinity, factor out x, we are left with 1 minus square root of 1 plus 1 over x squared. Now when I plug in infinity, I get infinity. 1 over infinity is 0. Square root of 1 is 1. 1 minus 1 is 0. So we have this. Awesome. So now we use the trick 1 over f, which is where I get 1 minus square root of 1 plus 1 over x squared divided by 1 over x. Now we have 0 divided by 0, and we can use L'Hopital rule to take care of the rest. So what do I have? I have denominator is negative 1 over x squared. That's cheap and fast. In the numerator, derivative 1 is 0. I have a negative 1 over 2 times the square root as is, times the derivative of the square root. It's going to be negative 1 over x cubed. Lies, negative 2 over x cubed. This is a negative here, so I can put it on a 1. There we go. I have 3 negative signs. I'm going to multiply everywhere by x squared to get rid of the double fraction at the same time. I can multiply by negative x squared, which will kill 2 negatives. So, the 2 and 2 cancel. There we go. So what do I have? Negative signs, 2 out of 3 are gone. X squared gone. So what's left is, I forgot the limit. X goes to infinity. What I have now is x in denominator. This one is gone, that's gone. So we have negative 1 divided by x times the square root of 1 plus 1 over x squared. And when you plug in infinity, you should get 0, because 1 over x squared is 1 over infinity. 1 over infinity is 0. And when you have 1 over infinity is 0, so the whole square root is just 1. And you have 1 over infinity, because you plug infinity for x as well. So when this is infinity, that's 0. So 1 plus 0 is 1. Square root of 1 is 1. 1 times x is x. So all of this stuff works out to be 1. So it's just negative 1 over x. So if this over here was x, the answer would be negative 1. But because it is 1, the answer is actually 0. So that was the case of infinity minus infinity. So far we have seen 0 divided by 0, infinity divided by infinity, 0 times infinity, infinity minus infinity. Cool. 3 cases left, which are exponential cases. All right? So we have, they all solve the same way. 1 to infinity, 0 to 0, infinity to 0 cases. The most famous of these cases is limit x goes to infinity of 1 plus 1 over x raised to the x. Does anyone know what this is? In Calc 2 you absolutely must know, but now it's okay. Would anyone like to take a stab at it?
1.
Nope. No. So it's not 0, it's not 1, it's not infinity. So let's discover what it is. How do we deal with these problems? Well, we have an issue of the exponent. And how do we get rid of exponents? Using what? ln, because the square root is only when it's a square, right? But this is x, which means can be anything. So we have to use ln to kill it off. Guys, the first step is to write y equals limit x goes to infinity 1 plus 1 over x to the x, and now we can sneak in 2 ln's. So in the next step, I'm going to, so ln y, I am going to kick the limit outside, and this becomes ln to this, so x ln 1 plus 1 over x. Those of you who forgot the formula, don't do that. We need 6 minutes. What did I just say? Are these guys DDoSing me from over there? All right, so the ln x to the p is p ln x. So that's how this x exponent went in front of ln. That is the formula you learned all the way in pre-calc 1. So a year ago, right, for most of you, at least. And we use that formula to move this x in front of ln. Now that you have that, we have, when you check this, we have infinity times 0. What's a 1 over infinity? 0. 1 plus 0 is 1. ln of 1 is 0. So we have this, which means that we can use the now 1 over f trick. So we'll put this in ln y is equal to the limit x goes to infinity, and then we have x. What do we have? We have ln, yeah, divided by 1 over x, yes. So now we have 0 over 0, and we can use L'Hopital, yes. ln y, put the L'Hopital up there. We have the limit, x goes to infinity, and now you take your limits. The denominator is good old negative 1 over x squared. The denominator now, I did ask on the exam to tell me the formula, and this is why I need you to know this formula. I asked you on the exam to tell me the formula for the derivative of ln of some function. And you were supposed to write f prime of x divided by f of x. Because of this, your limits now, your ln now, the derivatives of ln's, are not ln x. They are ln of some mess. So, the derivative of ln of some mess is Control C, Control V, right? Copy the mess in denominator and put its derivative on top. It's very important to do these derivatives correctly. So, I'm going to copy the denominator, in this case the function, so 1 plus 1 over x, and put its derivative on top, which is negative 1 over x squared. This is not a double fraction, it's like a triple function now. Fraction. You have to untangle all of this stuff. Well, depends on how well you know your algebra. You can consider all of this and then put over 1.
Couldn't you just multiply that bottom denominator to the very top numerator? Get
That's exactly what I want to work on, because now if I do over 1, this becomes negative 1 over x squared divided by 1 plus 1 over x times 1 over negative 1 over x squared. And then these guys cancel, as you would say. And now it's just 1 over 1 plus 1 over x. When you plug in infinity, you get 1 over 1, which becomes 1. And now you have ln of y is equal to 1. To get y alone, you e both sides. And what you get is, ln and e cancel, y equals e to the 1, which is e.
Yee. Like that, we're in class. You did it.
Now, from here, we know that y is equal to the whole limit. So if y is equal to the limit and y is equal to e, the limit equals to e, and this becomes your definition for number e. Coming back in chapter 7, coming back in chapters 10 and 11, in Calc 2, coming back in differential equations. Limit as x goes to infinity of 1 plus 1 over x raised to the x is equal to e. Put that one on a cloud. And then, modified version, limit x goes to infinity of 1 plus a over x raised to the bx is equal to e to the ab. If you know these formulas, you get to save yourself a lot of trouble later on. Dinner is ready. I hope that was not a last call for it. Another type of the problem, I know you want to go home, but is sine x, exactly, you should give up on this time, as x goes to 0. You can't solve this with any other limit method. So I'm just going to start you off on this problem. When you get home, you're totally not going to do it, right? Y equals, leave some space, limit x goes to 0 of sine x raised to the tangent x. Guys, this is awesome. For Thanksgiving dinner, it's like perfect. ln both sides. And that's going to give you ln of y is equal to kick the limit outside, x goes to 0, and then bring the tangent down, and then you have your ln of sine x. There is a times in between these. So now when you do the 0, tangent of 0 is 0. Sine of 0 is 0, but ln of 0 is negative infinity. So when you plug in, tangent of 0 is 0, sine of 0 is 0. But sine of 0 and then ln of 0 is negative infinity. So now you use 1 over f, and then that will change it into no, just take the derivative next step, write independent problems, and we're done. We will finish this chapter next class, so be here. That's Thursday, because we might vote on the next exam on Thursday, so make sure you're here. There probably is going to be a heated discussion to have it before or after Thanksgiving.
We have it on Thanksgiving.
So have it on the Thanksgiving because it's Thursday. Okay.
After.
I'll see it.
No, I can't remember that.